Greetings and welcome, internet friends and friends in the RL. That's right, because I'm recording this live. Today we were talking about section 2.5, proving statements about segments and angles. That's right, we are getting into the thick of geometry here. You just hang on, hold your geometric horses, get ready. It says, work with a partner. 4 steps of a proof are shown. Write the reasons for each statement. So here's a kind of 2-column proof pre-done for us. This is what I might refer to as a fill-in-the-blank proof for obvious reasons. So here we go. I've got given information. I've got my goal is to prove the following. And I've got a diagram that I could choose if I needed to label, but at this point it does not need any labeling. And so when we do a 2-column proof, I set it up with statements and reasons. And then here I make my mathematical statement. And then over there is my justification, of which I can pull from a toolkit of definitions, theorems, postulates, and the like. Also properties, I'm sure. So over here, I said statement 1, always a good choice. AC equals AB plus AB. All right. Interesting choice. The reason given. All right, like because that's right there. That's why it's true, because they told me so. All right, statement number 2, AB plus BC equals AC. So AB, this guy, right, plus BC is equal to the entire length. Why do we think that's true, friends? I don't know that yet. Now, it wasn't officially told to me yet, but I agree you're on the right track. Yeah, we had a name for that. It was segment addition postulate. All right, segment addition postulate. Let's see. I'm going to actually here pull this up. Let's see. I'm going to go to my brush puck. I'm going to turn this down to like 3.3. That feels a little bit better. You guys think so? Yeah, I think I'm writing chunky here. All right, there we go. So, segment addition postulate is what says that the length of the entire thing is equal to the sum of the non-overlapping parts. All right, we also had area addition postulate. We also had angle addition postulate, all basically saying the same thing. All right, here now what we're seeing is AB plus AB is equal to AB plus BC. Does anyone see what happened there? I think what they did was this. If these two things are equal, they then substituted this in for AC. Okay? So that, I believe, is the substitution property, subs prop of equality. Man, I really like that yellow on the blue. I like satisfying. I like it. It's good. Good stuff. All right. Okay. Here we go. Here we go. So substitution property of equality. Oh, I actually see another option that the book was choosing to using. You also could have done, here I'll do alternate universe, parallel dimension. It also could have been transitive property of equality. All right, check out. The reason transitive would have worked is because if AB plus AB is equal to AC, and if AC is equal to this, then this guy and this guy must also be equal. What I see in statement 3. All right, which, by the way, transitive property really is just like a particular case of the substitution property of equality. So either of those reasons would have been sufficient right there. Let's see, and lastly, we've got AB equals BC. How could I go from this statement to that one? Or maybe a consolidation. Ooh, good eye. Man, subtract AB from both sides, right? And we'd be left with AB is equal to BC. And yeah, so subtraction, that's why I've got my abbreviation for subs and subbed have to go out 4 letters. Subtraction property of equality. And now it's proven. I just proved it. But guys, check this out. Someone made a statement earlier we could actually take this one step further. We could say that B is the midpoint. I know they didn't go this far, but we will. Of what? B is the midpoint of what? I know I just ruined my picture here. Looks like AC. And the reason that would be true, let's see, I'll write little 3A's and 5 over here. Does anyone know why that would be true? Definition of midpoint, MP. Because if it divides the segment into two equal lengths, then it must be the midpoint. I mean, arguably, maybe I could have thrown another piece in there saying segment AB is congruent to segment BC by def of Cong, but I think we're good with this one right here. Let's see. So I don't always do these exploration problems, but I think today, especially because these are like fill in the blank proofs, I guess, that I kind of like these. So I'm gonna give us another one here. My in real life friends have not yet seen this one. So here we go. So I'll give a moment for my IRL friends to draw this little picture. Like we've got C, B, E, D, A, or probably A, B, C. Oh, I actually don't see a real pattern that they use to construct this. Oh man, here they gave us the reasons, and we're filling in the statements. Wow. Yeah, proofs take a little while to get adjusted to. I mean, they're not just simply algebraic algorithms that we process through of like, oh, I just get it X by itself. I'm not following an order of operations. Really, like this is some of the highest order thinking that you do throughout high school mathematics, where you come to the table with your toolkit of definitions, theorems, postulates, properties, and now you're trying to like write a paragraph that justifies and proves a particular statement or property. So like you got to come to the table, and I can't just give you like an ordered system here. I'm going to try to give you all the tips and tricks I can throughout this course. But man, proofs. Yeah, I can't. It's not just like, you know, sometimes these are a little bit open-ended. So here we're setting us up. Success. Let's see. Here we go. So they said given the measure of angle 1 is equal to the measure of angle 3. Oh, nice. They even actually labeled that for us here. Right. They want us to prove the measure of angle EBA. Here we go. EBA, like so. I'll underline that guy with that color. And the measure of angle is equal to the measure of angle CBD. CBD, right there. Look at that. Gorgeous. So that's what I'm trying to prove. Notice those angles are kind of like macro angles. They're composed of smaller pieces. Now, all right, here we go. Statement number 1. The reason they said was given. What do you think the statement's going to be? Should be the gimme here. Yeah, right? Like I can at least pick up those points on a short answer quiz question, right? Like oh yeah, that makes a lot of sense. I like it a lot. So the measure of angle 1 is equal to the measure of angle 3. Given. That's a good enough reason for me. Someone told me, and now I'm solving this problem. Right? You told me, book. That's why it's true. I trusted you, book. Come on. What's the big idea here? So let's see. Then they said the measure of EBA is equal to the measure of 2 plus measure of 3. EBA, that was my yellow angle, is equal to 2 plus 3. The reason that's true is angle addition postulate. You can ignore memorizing postulate 1.4. That's going to be different for just about every textbook you ever read, so no worries there. But that makes sense, right? The yellow angle is equal to the sum of the two smaller angles. Yep. Then they said the measure of EBA is equal to the measure of angle 2 plus the measure of angle 1. What changed between these two statements here? Yeah, it looks like they replaced the measure of angle 3 with this measure of angle 1. And they were allowed to do that by the substitution property of equality. You guys better be so thankful I don't make you write those words out fully. I let you abbreviate. You are fortunate friends right here. I might be, I don't know. I don't even know if it's department protocol, but I'm pretty sure I'm breaking it. Here we go. Substitution property of equality. Okay, so now let's see. Commutative property of addition. Anyone know what the commutative property of addition says? Basically, it says that if I'm adding two numbers, I can add them 1 plus 2 or 2 plus 1. So let's swap it around here, friends. Swap it around. So I'll change this to measure of angle 1 plus, you get a better plus sign here, the measure of angle dos. Hey. Okay. All right. Now their next claim, I'm checking this, is an angle addition postulate. This next claim is somewhat unrelated to all of these. Okay, it's not going to be related. But looking at the diagram, using angle addition postulate, what would the measure of angle 1 plus the measure of 2 equal? CBD, right? We'll call that, oh, I got to have the little m, measure of angle CBD. All right. Now let's see, transitive property of equality. Transitive train, right? Here we go. I've got, let's see, I've got m EBA is equal to this. And that is equal to this. Therefore, I can just cut out the middleman and assume that these two things are going to be equal, which also, notice, is what I set out to prove. And so the last statement should probably be the thing that I set out to prove. So the measure of angle EBA is equal to the measure of angle CBD, right? So in combination of this diagram, bunch of properties in it. Ooh, look at those colors, guys. Wow, I love this. I'm going to hang this on my fridge. Pumped. Yeah. Man. Actually, I wonder if I could just get one of those fridges with like a 7-inch tablet built into it, and I'll just like open up YouTube on it, and I'll just like play this video on loop forever on my fridge, just because I'm so proud of how good this turned out. Good stuff. Good stuff. So, so are you guys tracking with this? I mean, it's a little bit weird. It takes a little bit of time to get used to here. I've got another one for you. Another fill in the blank one because I'm being friendly. All right. All right. Taking our time. All right. So I'll give you a moment to draw the picture right here. You could write, you know, kind of your given, and you could write down what we're setting out to prove. Prove here. Man. Proofs. Yeah, so you are definitely going to want to be familiar with definitions, theorems, postulates, and properties, because that's where your reasons come from, right? Right. Here we go. So I've got, here's 3 points that are collinear. They're on a segment. Oh, given T is the midpoint of SU. All right. I'm kind of thinking now if we didn't have this yet, all right, and you're like, okay, T is the midpoint of SU, you should be able to look at this and already start thinking of some additional facts that you could say and justify, right? Like I'm thinking like this guy equals this guy is what I'm going to be saying eventually, right? That seems to make sense. And I'm trying to prove what X is equal to. All right, here we go. Let's try this. Let's see. Statement 1, T is the midpoint of SU. The reason? Given. Seriously, like everybody on these proofs should get the first point. It's a gimme point, right? Look at we've got some momentum going here now. We are well on our way proving stuff. Let's see. Statement 2, they said ST is congruent to TU. All right. The reason that's true is def of MP. Sorry that you guys have to write this down. I tried today. Really did. So let's see. Def of MP is a sufficient way to abbreviate that in my world. Although that's like math on the street, Waddy math. Other mathematicians, they might want some full words there. Okay, notice the subtle difference between these two statements. Congruence is describing the picture, the actual diagram of this segment being the same as that segment, okay? Whereas equality is now referring to the numbers that represent their lengths. And whenever I go from congruence to equality or equality to congruence, the way I do that is def of Cong, right? Def of Cong, right? Def of Cong. Makes sense? If the segments are congruent, then their measures are equal. And now if their measures are equal, oh, I know a way to represent those measures as these algebraic expressions. What do you think we did here? Maybe if I use this color, it'll help out. And what do you think I did here? What's my reason? Subs, prop, equality. Right? If 7x is another way to describe the length of ST and 3x plus 20 is another way to describe the length of TU, I can interchange those things at any time I like. All right. Now, here they're telling us my next move was subtraction property of equality. Now they don't write this move, but what they would have been subtracting was 3x from both sides. 7x minus 3x is going to equal what? How many x's? 7 apples minus 3 apples is 4 apples, right? So I'm going to get 4x equals 20. The reason that's true, subtraction property of equality. Now notice that your book doesn't consider that a step. That's like your work. It might be a good idea for you to still write that down, although you don't have to give your reason for it. You just state your reason next to your statement. Okay, I'm still a fan of doing this at times. And let's see, how could I get from here to here? 5 to 6. What algebra allows such witchcraft? Yeah, division. Divide both sides by 4. And the reason that's true is div prop equal. Right? Making sense? And I'm done because it's proven. I proved it, friends. Let's see. So you guys don't have to write this down, but I'll put it up here. Where's my scroll bar here? All right, how are we feeling so far? All right, proofs. We're just like pulling from our data bank. Let's see, here we go. You don't have to write this down. It says the reasons used in a proof can include definitions, properties, postulates, and theorems. Oh, definition of a theorem. We've heard of the word theorem before, like the Pythagorean theorem. But it says a theorem is a statement that can be proven. Once you have proven a theorem, you can use the theorem as a reason in other proofs. How cool is that? This math just keeps building upon itself, getting stronger every day the more things that I prove. How wonderful is this? I love it. Okay. Here's some theorems. Do I have to prove these theorems? No, we're just gonna give these to you. Yeah, you don't have to write these down. These are found in Sus Libro, in the lesson plan. Here are some theorems. All right. Here they're saying that segment congruence is reflexive, symmetric, and transitive. All right, so reflexive property of congruence is that any segment is congruent to itself. This one will actually, oddly enough, show up quite a bit. Here's like future problem where we'll be trying to like prove that these two triangles are congruent, and I'll know like this and this are congruent, and I'll know like this and this are congruent, and we'll be like, where's my other information? And this is exactly what we'll do. Like, we'll be like, wait a minute, this segment is congruent to itself by the reflexive property of congruence. Right there. So that's definitely true. That's useful. Symmetric property of congruence. If A equals B, then B equals, right? A equals B, then B equals A. Yeah. Also true for congruence with segments. And then transitive property. You've seen all these before. It's the same reflexive, symmetric, and transitive. It applies for segments as well as angles. I don't think you necessarily have to write these down. Like I said, these are in your book. And it's the same exact idea, except in this case, instead of applying it to equality, we'll just write reflexive property of Cong for congruence, right? And we'll be awesome. Let's see. Let me get one more example in here, maybe. Yeah. All right. Yeah, we'll prove one of these because these are theorems, friends. And what did I just tell you about theorems? I told you that theorems can be proven. What about postulates, right? Postulates are statements we believe are true without proof, where theorems, we prove them true, right? Okay, here we go. Last example of the day. I'm going to set this up here. Last example of the day. And we're going to have time for party quests. Wait a minute, that's weird. That is weird. You guys see like the weird... That's all I'm saying. Huh. Let me try this again. I've never seen that occur before. Okay. Wow, you saw that, right? I wasn't just imagining. I don't know if our internet friends saw it, but it was like showing up an illusion from the previous thing. Okay, here we go. So write a two-column proof for the symmetric property of segment congruence. All right, guys, this is scary, right? Like this proof is just blank. It's just staring at us. All right, given information, LM is congruent to NP. So I would draw the picture and I would label it, and it was already labeled. So congruent. I'm trying to prove that NP is congruent to LM. All right, where's a good place to start for our proof, friends? Probably with the given information. So I'm going to start with LM is congruent to NP. The reason, given. All right. Let's see, next thing I can say. And what's nice is once I prove this, I never have to prove it again because this will be a theorem, right? And then I can just use this as its own theorem. Okay, how about this? Do you guys think this is true? LM is equal to NP. You guys believe that? If the segments are congruent, their lengths are equal. Reason, depth of everybody's favorite, congruence, def of Cong. Arguably, definition of congruence, segments. I'm fine with abbreviating that where you don't even necessarily need to say segments. You say def of Cong, I know what's up. All right. Okay, how about this? Now, I'm trying to prove that congruence is symmetric. I've just translated into the world of equality. I already know that equality is symmetric. So I'm going to say NP is equal to LM. Which property says that's true? The symmetric property of equality. Now I'm proving the one about congruence here, okay? So here, look at this. Wow. How cool is that? I love it. And let's see. I think I can write my last step. I'm going to write it. NP is congruent to LM. Anyone know why that's true? How could I go from this to this? How can I translate from equality to congruence? It's already written on the screen once. F of Kong. Donkey Kong. Here we go. I like it. So yeah, anytime I translate from congruence to equality, def of Kong. I go back, equality to congruence, def of Kong. Definitions are biconditional, friends. Of course, you already knew that. All right, thanks for watching, internet friends. From all your friends in real life, bye. We're waving at you. Is there like an emoji for waving? Gotta be, right? Like these probably just gotta have like little swoop lines on it or something. Is there a way? Yeah, waving. I'll just put like asterisk waving in like the comments below. It'll be good. If you want to wave back to me, feel free. You can wave back. Bye-bye.